Good morning, Santonio. Good morning, Isabella. Good morning, Dr. Laughlin. Good morning, Jonah. Good morning, Victor. Good morning, Danielle. Good morning, Dahlia.
Hi, Mr. Dutton.
How you feeling?
I'm good.
Good.
I exercised for the first time in forever yesterday.
Woo!
I'm sore.
Good, good. Make that a daily routine.
Hi, guys. Hi, Danielle.
Morning, Danielle.
Hi.
Morning, Julio.
Good morning.
Welcome, DJ.
I have my camera turned off. No, I'm not embarrassed.
Morning, Vivian.
Morning.
All right, so do me a favor and in the chat, either privately to me or to everybody, put your answer to the spell work that's up. Good morning, Angelina. All right, I'm going to mute some folks so that we're getting a little bit less crowd noise here. Okay, thank you, Victor, for submitting the bell work. Take another minute and please submit your answer to the bell work either privately to me or to the whole group. Thank you, Vivian, for submitting the bell work. While you're submitting bell work, I hope that you get to enjoy some of the day. I know it's rainy on and off, but it's a beautiful day, nice and warm, relatively speaking. Of course, I say that the instant it begins to rain again. Thank you, Julio and Jonah. All right, take another few seconds, and then I'm going to start by finishing, as I said, the test review. And then we'll talk about the lab that we did yesterday, or that I did and that you all participated in. Welcome, Mr. Persiak. So for the bell work, I'm getting a lot of the same answer, which is great. You're starting with, whoops. Didn't mean to send that to you, Julio. All right. We're starting with F equals mg because it's definitely F equals ma and the acceleration is due to gravity. And then we're having to multiply it by either the sine or the cosine of the angle. And the reason I say either the sine or the cosine of the angle is it depends on which angle you have, which angle has been measured. And as we'll see in the test review, you're going to use either sine or cosine in order to determine what that component is. All right, so let's go out to that test review in just a minute. I'm going to make sure folks are muted so we don't get feedback. Then we'll be going over the rotational derby lab. As a result of the survey that you guys took yesterday, I made some decisions about spring break. Some people did request to have normal classes during spring break, but that was not the majority. And so most people said that they wanted to have sessions on Monday, Wednesday, and Friday. So I'm going to offer Monday, Wednesday, and Friday from 9 a.m. to noon, basically the same hours that I've been putting in. So that keeps me on my routine. During that time, we are going to do some Q&A. So you can bring whatever questions that you have. It can be about coursework. It can be about current events. And so this will be all my students, including, environmental, computer science, physics. I'll handle as many questions as I can. I'm inviting other folks to get on this. So other teachers to get on, and I'll try to do as much through individual chats and screen shares as I can. If everyone is having same questions, then I'll of course screen share that. But I'm going to rotate through also some meditation and exercise breaks. So especially those of you who are starting to see the value of being physically active during this time when you're less physically active, just giving you some ideas as to things that you can do at home, especially if it keeps raining. And making sure that we're setting some goals and getting some routines set up. So that's what we're going to mostly be doing during that time. If you want to individually talk to me, if you have some other things that you want to go over outside of those times, please reach out. I'm more than happy to set up some other times, either on Tuesday and Thursday or during the afternoons. Any questions about the spring break schedule? All right. And I just wanted to really briefly go over the things that I talked about earlier in the week, emphasizing establishing a routine, doing some reading, getting some non-screen time in, doing whatever exercising that you can. Also reaching out to others, especially others who maybe haven't been getting on these Zoom meetings. And you never know who you might connect with. They might just need to hear from somebody else. They might be feeling really lonely. It's super easy to feel lonely during these times. Try as much as you can to keep up with your studies. I really want you to be all caught up. Like I said, this can be the lab that we did yesterday. You can write up as a lab report and it'll count as a lab report, or you can just write it up as an activity and I'll count it as an activity. I leave it up to you. It depends on where you are with your studies and how much effort you want to put into this. And really take seriously making a schedule for yourself. I know some folks are telling me that they're waking up too late for the classes. But the reason that I have the classes when I do is to get people up in the morning and stay in that routine as much as possible. So let's go over the last couple questions of the test. And I'm sure that I clicked on the wrong, yeah, totally clicked on the wrong one. Because all my windows are named the same thing. There we go. So here's what we didn't finish. Number 86. And we did not talk about either numbers 14 or 15 yet. Let me make this bigger so that everyone can see it, no matter the size of your screen. Okay, so number 14, we have a 25 kilogram box is pulled across a frictionless surface by a 70 Newton force at an angle of 30 degrees to the horizontal. And this is the same question, except with different numbers, that I asked you before in an activity sheet. So, what steps do we need to follow in order to determine the acceleration of the box in the x direction?
Can you say it again?
Yep, as soon as I can breathe. Okay. What steps do we need to follow to determine the acceleration of the box in the x direction? This one right here.
Doesn't it have something to do with cosine? Like,
I hear a very muffly voice.
sorry, I don't know if that's my speaker. Can you hear me now?
So I see that you're speaking, Vivian. If you want to, can't really catch your audio. If you want to participate in the chat.
Can you hear me? I don't know if it's something wrong with my computer or...
I can hear you, Vivian.
Okay, so Dahlia can hear me.
Oh, now I can hear you better. It could
Okay.
totally be on my end.
I don't know. Sorry. Don't you... Wait, what's the force in the day? It's 7G newtons. So it's like, you set up the equation like cosine of 30 equals, what is it? 7, or x over 70 newtons. And then you like use algebra. Something like
Good.
that.
Okay, so here's our triangle, right? I completely agree with you. So here's our, whoops. I need to draw this differently. Here's our angle. And so Vivian, you said that the cosine of 30 is going to give us what?
X over 70 newtons.
So this measurement x, right?
Yeah.
So let me just draw it again right here. X, and you said the magnitude of this force is 70 newtons.
Mm-hmm.
That is horrible. I think I need to go back to second grade. All right. So the magnitude of this force is 70 newtons. And then this is our x. And just to kind of really boil it down, remember in trigonometry, the cosine of an angle is equal to the adjacent over the hypotenuse. And so this 30 degrees, the adjacent length is this x. And the hypotenuse, we know, is 70 newtons because that is the applied force. That is the direction of the applied force. So we have cosine of 30 equals x over 70 newtons. And how do we get that x all by itself?
Multiply each side by 70 newtons.
Multiply each side by 70 newtons. So we need to find out what the cosine of 30 is, which we keep seeing again and again. What is the cosine of 30? Cosine of 30. So did everyone get 0.866? All right, I'm going to assume that's a yes. Your silence is affirmative. All right, 0.866 times 70.0 newtons equals we have three significant figures. Don't be afraid to unmute yourself.
60.6.
Awesome. Thank you. 60.6 newtons. So that means putting this back in, just to really go full circle on this, that means that this force in the x direction is 60.6 newtons. And if we wanted to, we could even calculate this force over here, the vertical force, if we took the sine of that angle, but we're concerned about what it is in the horizontal direction, in the x direction. So that gives us a force. Are we done? Do we have an answer to this question?
No.
No, we do not. What formula do we need in order to actually determine the acceleration of the box in the x direction?
F equals ma.
Yeah, all right, F equals ma. So we have a force, and that's 60.6 newtons. We have a mass. What's the mass of this box?
Does it say 25 kilograms?
25.0 kilograms, excellent. And we're multiplying that by our unknown acceleration. What do we need to do to both sides in order to determine the acceleration?
Divide by 20.
Divide by 25 kilograms. And so that gets us an acceleration of 2.42. What are my units on this?
Meters per second squared.
Meters per second squared.
Could you scroll it down a little bit so we can see?
Yep. Let me get rid of this drawing here. Oh. Stop. Yeah. And so the easier one is calculating the normal force from the floor on the box. For that, we're going to need what?
Isn't that just mass times gravity?
It is. So the mass of the box is 25.0 kilograms. And let's go all scientific and use 9.8 meters per second squared. What do we get?
245.
I agree with you. $245 what?
Newtons.
Newtons. All right, I'm going to move on to number 15. I'll leave part B up there. So we have here a 30 kg block. And on your copies, I apologize, I think I did not crop it. So I think it says 20 up there. But I did change that mass. If you did it with a different mass, just show your work. So 30 kilogram block is allowed to accelerate down a ramp with negligible friction, so we don't have to worry about the coefficient of friction. First of all, draw a force diagram for the block. So you'll have some sort of block. What are the directions of the forces on this block?
The ramp is pushing up on the block.
The ramp is pushing up on the block. Excellent. What else?
Gravity is pushing down on the block.
Gravity is pushing down on the block. What else?
Frictional force to the left.
I agree with you. In this case, we are neglecting friction,
Okay.
right? But yes. And then what is pulling it to the right? This is probably the trickiest part. What's pulling it to the right?
Also gravity.
Yep. So, well, that failed. So this is normal force. This is gravity. This is also gravity. And the reason gravity is acting in both of those directions is because it's acting on the diagonal. So it's both pulling it right and pulling it down. All right, so our next step here is to determine the acceleration of the block. So how can we start this?
Mass times gravity times the sine of the angle.
Okay, so all right. So you're saying mass times gravity times the sine of the angle. All right, let's make sure we understand why we're saying that and confirm that that is correct. So here is our mass. The full force of gravity is acting in this direction, but this mass is moving in this direction. Since it's moving on the diagonal, we want to know what component, what fraction of gravity is actually acting on this block as it's on this inclined plane. For this angle of 25 degrees, gravity is the opposite measurement to the hypotenuse. So let's be really clear about what that sine of 25 means. So that sine of 25 is taking the ratio of gravity over x. The full extent of gravity over x. So that's going to tell us what fraction of x is happening here. So you're absolutely right, Victor. We're taking mass times gravity times the sine of 25. So the mass is 30.0 kilograms. Gravity, let's use the full amount, 9.8 meters per second squared. And then we need to take the sine of 25 degrees. All right, I think you should get that. You should get something like 0.42. The reason I'm saying 0.42 is that we used a value for gravity that only has two significant figures. So if we multiply that all out, what do we get? We get an email. Get 124, what are the units on that? All right, thank you. Newtons. So we get 124 newtons. Are we done? Does this tell us what the acceleration is? Feel free to respond in the chat or to unmute. What do we need to do in order to determine what the acceleration is?
F equals ma.
All right. So we have a force. We have mass. What's the mass, real quick?
30 kilograms.
Awesome. And then we can determine that acceleration. We do not have to use sine or cosine on that acceleration because we know what the applied force is. Okay, so just to make it super, super clear as I can, this force here was due to mass times gravity. This force here was due to mass, gravity, times sine of 25. So this tells us what the force would be if it were just on the vertical. And this tells us what this force is now, which is 124 newtons. And that is simply that applied force applied to this 30 kilogram object. Now that we have that, all we need to do is some algebra. And our acceleration is going to be equal to 124 newtons divided by 30.0 kilograms, which is what?
.1 and then a bunch of threes.
Okay, so two significant figures, 4.1 meters per second squared. That thing's cruising. All right. And finally, would the acceleration be different if the mass of the block were 10 kilograms? Here's what you should do. You should set up F equals ma.
Said yes.
Why'd you say yes, Victor?
Because when it comes to F equals ma, the acceleration will be twice as great.
If it were 20 kilograms, yes. I'm using 30 kilograms, so it would be how many times as great?
Oh.
I get 3 times as great. But same idea. Absolutely, the acceleration would be different.
Excuse me, Mr. Dunn. I'm going to leave.
Okay.
Unless it's needs computer. Bye, and I'll make sure I watch the recording.
All right. So let's move on to, unless there are any other questions. Let's move on to oh, wait. Wait. Y'all distracted me.
How so, Mr. Dutton? What happened?
I was all ready to move on. But look, what if we have to do this over again for a 10-kilogram mass?
I mean, you would, right? Because the force would be different if it were 10 kilograms. Instead of
Yes. Absolutely. So look what happens. $41 newtons. The force is different. And then the instant that force is different, look what happens to that acceleration.
Wow, it's the same.
Yeah, I knew that didn't sound right. Okay, so that mass has an influence on how much force is actually being applied by gravity. And then it's going to influence the total acceleration based on that force. So the mass shouldn't matter, although if there's friction, then it would matter because the amount of friction would depend on the normal force. But disregarding friction, those should move down the same. All right, so let's move on really quick to the lab from yesterday. And I want to give you guys the opportunity to ask about some of these analysis questions. As I said, you can write this up as a whole lab report if you want to. You can also just submit it as answers to all of these analysis questions and it will count as an activity. I leave it up to you as to what you want to do. But those of you who maybe have low lab report grade, you might want to take this opportunity to write it up as one.
Wait, so just to clarify, all we really have to do is answer the analysis questions, and then making it into a lab report is optional?
Yep.
Okay.
So if you answer the analysis questions, then it will count as an activity sheet. So that would be one criterion worth. And if it's a lab report, then it would be both criteria B and C.
All right, cool.
So what questions do you have about these analysis questions? Feel free to ask your question in the chat or to unmute.
In the last question, in number 10, what does it mean by like the greatest resistance to rotational acceleration?
So remember, inertia is an object wants to stay in motion if it's already in motion, but if it's not, it wants to stay at rest.
Okay.
So at the beginning, what we saw yesterday is that we saw some objects like to move right out the gate because they had low inertia. And so moving from a rest was really easy for them. But some other objects, it took a while for them to get going. And so they had large rotational inertia because it took them longer to start moving from rest.
So like the cans that had water in them, those had greater resistance to rotational. Okay, all right, cool.
Absolutely.
That's all I needed to know.
So to answer this first question, I'll just go through really quick while folks are still on, because you're being shy. For this first question, the two solid spheres of different diameters, we did that with the lacrosse ball and the baseball. And so you should have some data about which one took longer. If you want to think about that differently, think about how a marble versus like an exercise ball like this big honkin' sphere, how those two might be different rolling down an incline. You can imagine that one of them would start moving much faster than the other one because of rotational inertia. All right, the marble would pretty much get started right away, whereas this exercise ball is going to take its time to start to move. It's got more rotational inertia. But once it's going, it can take out your 3-year-old little sister. Number 2, what do you conclude about the time it takes for 2 hollow cylinders of different diameters to roll down the same incline? So the example yesterday was the street hockey ball and the tennis ball. They're slightly different diameters, but understand there was a difference with how much material was on the outside. Number 3, what do you conclude about the time it takes for 2 solid cylinders? I'm sorry, I answered number 2 for spheres and not cylinders, but that comes up later. So for number 2, the hollow cylinders of different diameters were these 2. So the tomato paste empty container and the can of kidney beans empty container. 2 solid cylinders of different diameters, that would be the full tomato paste and the full tomatoes. 1 hollow and 1 solid cylinder to roll down the same incline. That would be these 2. We did that in a couple different ways. And remember that your answer should take into account the rotational inertia based on where the mass is focused. All right, which one had more rotational inertia? Solid sphere and solid cylinder. I think we use the lacrosse ball. I don't have the lacrosse ball today, but solid cylinder, solid sphere, and then solid sphere and hollow cylinder. And then the sloshing liquid versus the non-sloshing solid contents. That was where we had the can O socks and the liquid. I forget if we used the can O socks against the liquid, but we definitely had a non-sloshing cylinder. And then which took the least time, which one went down the fastest. I think it should be pretty straightforward at this point. Any other questions about doing this analysis or the lab report? Now I'll sit on the exercise ball. Okay, is anyone still there? Or are you just leaving it running so it looks like you're still there?
And I'm here.
Hey, all right. Any other questions?
I don't have any questions as of right now, but if I do come across something, I can still email you, right?
Absolutely. I am making myself as available as I can. About all I'm going to be doing outside of being at home is we are picking up some groceries, but we're not going into the store. I don't know how you guys are handling that, how your families are handling that, but we're putting in orders and we are picking up the order so that we don't strain the delivery services. But we're not going in the store. Outside of that, I am available. So email me if you want to get on Zoom to do a screen share because you need to be able to see it. Schedule a time with me. I'm more than happy to schedule that time. You guys are my first priority, so let me know. Okay?
All right.
All right. Have a wonderful weekend. Get in contact with me if you need anything, need any help. And then remember, next week, Monday, Wednesday, Friday, 9 to 12 is when I'm getting on for Q&A and other spring breaky kind of things. All right. Have a great weekend.